AI is disrupting countless industries, just like electricity did in the past. From enabling self-driving cars, to analyzing medical imagery, to predicting retail demand, detecting fraudulent financial transactions, and even generating highly realistic images and text using generative AI, the applications are endless. In this episode, I'll be showing you more than 50 AI use cases across different domains. Welcome to the second episode of the AI for Business course, your ultimate non-technical intro to AI and how to apply it in the real world. If you don't have a ton of expertise in AI, but you truly wish to get into it and understand how to use it in your work, this course will absolutely help you in realizing that goal. In the previous episode, we got introduced to how AI and machine learning work. In this episode, our focus will be on AI use cases and applications. So without further ado, let's get started. Firstly, if you are eager to explore numerous AI use cases in different domains, I recommend visiting ai-cases.com. I've put together that website to help anyone understand the most critical use cases in different sectors, including supply chain, manufacturing, health, insurance, banking, education, and more. The website is structured in a way to provide a high-level introduction to each use case, followed by more in-depth resources, including case studies, technical explanations, code samples, research papers, off-the-shelf products, and a community space for asking questions and sharing knowledge. While we could try to list all known use cases in different industries, it would be a daunting task. Working with many customers for the past 13 years, I've found that learning about the common patterns underlying these use cases is generally more important than simply learning specific examples. By grasping these patterns, you're going to find it much easier to conceptualize and visualize possible use cases in your work. There are 8 major patterns of which most AI cases could be grouped under today. In this episode, we're going to see each of those patterns and explore different use cases that belong to it. Those patterns are prediction, clustering, anomaly detection, computer vision, natural language understanding, voice analytics, action optimization, content generation, or generative AI. We'll dedicate the next episode only for generative AI, given the significant recent developments taking place in this promising field. From writing full articles to generating highly realistic images, videos, and audio, to chatting with enterprise data, to building AI autonomous agents that could carry on whole tasks, there is an enormous opportunity in so many different sectors. Now, let's focus on the first pattern we have today, prediction, and see how AI could help us make informed decisions based on historical data. As discussed in the previous episode, machine learning models could be used to make predictions about the future when trained with historical input-output data. If you'd like to know more about how this type and other types of machine learning work, I highly recommend watching that episode. Now let's take a closer look at 12 examples of how machine learning could help make predictions in different industries. One versatile use case that could be applied across different contexts is personalized recommendations. AI can offer tailored suggestions based on user behavior and preferences by analyzing patterns in the data and learning to predict what the user might be interested in next. Machine learning algorithms can analyze user interactions, browsing history, and preferences and make predictions on what they might like next, leading to tailored suggestions and a more engaging and personalized experience. For instance, e-commerce platforms like Amazon can recommend products to buy based on users' purchasing behavior and browsing history. Social networks such as Facebook and Twitter can curate personalized content for users' timelines, considering factors like app usage and interests. Streaming services like Netflix can suggest movies and shows based on viewers' watching history and preferences. Now, let's delve into industry-specific use cases that use predictive analytics. In retail, for example, marketing teams could enhance their return on investment by leveraging hyper-targeted promotions. Machine learning could be used to predict the next best coupon, offer, promotion, or discount for each customer, ensuring they get the promotion that they're likely to engage with and use. Operations team can enhance efficiency with demand forecasting, where AI can estimate future product demand and help with automating replenishment per store. Dynamic price optimization, where machine learning can help find the optimal price for a product or service based on multiple factors like weather, time, competition, promotions, etc. This one is pretty famous among hotels and airlines especially. In supply chain, AI can improve various aspects of the process, including predicting delivery times. Machine learning can estimate accurate delivery times based on factors like geography, time of the day, and product, setting customer expectations and optimizing planning. Optimizing the logistics and delivery network. AI can enhance the logistics network based on forecasted demand, improving efficiency and reducing costs. Automating procurement operations. Machine learning can streamline processes like spend management, supplier management, and capabilities matching, leading to more efficient procurement. In manufacturing, a classical use case is predictive maintenance, where machine learning could help predict possible failures in machines before they happen and help reduce downtime and potentially reduce a lot of costs. This happens when we use machine learning to analyze anomalies in sensor readings of those machines, like temperature, vibration, pressure, and more. In banking, AI could be used to assess the credit risk for loan applicants. By analyzing data like the recent credit history of applicant, the income level, and more, this risk score could be assigned and help banks make informed decisions. In insurance, personalized policy pricing is a major use case. By forecasting the risk per applicant based on multiple factors, machine learning could help personalize the policy pricing for each candidate. In healthcare, two major examples of using predictive analytics include precision medicine, where AI can recommend the best treatment likely to work for a patient based on their genetic history, genomic sequencing, medical records, and more, and predicting hospital readmissions, where machine learning could help estimate the likelihood of a patient potentially being readmitted to the hospital. This could improve resource management and patient care big time. These were just few examples of how machine learning could be used to make predictions in different sectors. The details of each use case is explained on ai-cases.com, where you can find more resources that can help you understand the use case and further implement it. With that said, it's time to move to the next pattern, clustering. As we discussed in the previous episode, clustering is a powerful technique that can help you find natural groupings in your data. It works by grouping data points with similar attributes and assigning them to distinct clusters. A major use case here is customer microsegmentation, where machine learning can help you discover unique groupings of customers based on their characteristics or behaviors. These insights can then be used to tailor marketing campaigns and guide new product development. Clustering could also be used in other contexts, such as fake news detection. Machine learning could be used to cluster articles based on their textual content, enabling the differentiation between authentic and fabricated news stories. Another application is patient stratification, where clustering could be used to group patients with similar medical conditions, treatment histories, or demographics. This helps healthcare providers identify subpopulations of patients that may require tailored treatment plans or personalized care. Now, let's discuss the third pattern, anomaly detection. This one is all about finding data points that deviate significantly from the majority or expected patterns. Machine learning is really good at finding these outliers, especially when labeled data for those rare events we're interested in detecting is limited. Let's take a closer look at a few key examples of anomaly detection across various industries, starting with fraud detection. In the world of finance, anomaly detection is a game changer. It can help detect unusual spending patterns, transactions, suspicious insurance claims, and potential money laundering schemes, making financial systems more secure and trustworthy. Transitioning to healthcare, anomaly detection can make a world of difference. It contributes to reducing medication errors by flagging prescriptions that conflict with a patient's profile and identifying rare conditions or unusual patient symptoms, ensuring better patient care and outcomes. In the realm of manufacturing, anomaly detection proves its value once again. In cases where limited historical failure data is available, it can support predictive maintenance by analyzing sensor data and identifying potential indicators of future failures. In cybersecurity, AI-powered anomaly detection can identify intrusions or data breaches by detecting unusual network activities, login patterns, or data access and usage patterns, allowing organizations to respond quickly and protect their systems. In the next part of this video, we'll explore the fourth pattern, computer vision, and how it enables AI systems to perceive and understand visual information from the world around us. With the power of modern deep learning, AI systems can detect objects in images or videos with incredible accuracy, often on par with or even surpassing human capabilities. This opens up numerous possibilities for automating tasks that require processing large amounts of visual data. If you want to understand what deep learning is and how it works, I recommend you watch the previous episode of this course. Now, let's take a look at a few examples of computer vision use cases in different industries. Visual quality inspection. In manufacturing, computer vision can be used to detect defects in parts or products, ensuring quality control. Diagnosis of medical imaging. AI can extract insights and detect anomalies in X-rays, CT scans, MRIs, and other medical imaging modalities, enabling early diagnosis of diseases like cancer or diabetes. Pathological analysis and smart surgical assistance. Computer vision can be employed in healthcare to assist with pathological analysis and provide guidance during surgical procedures. Property analysis from imagery. In insurance, AI can identify property risk factors using geospatial imagery, detecting features like skylights, solar panels, pools, and roof conditions. Autonomous vehicles and robots. These systems rely on computer vision AI to perceive and understand their environments, plan their actions, and navigate. In the retail space, computer vision can support automated shelf tracking and management, theft detection, and in-store customer behavior analysis. Digital map creation. AI can extract features like building footprints, road segments, and land cover from satellite or drone imagery to automate the process of creating digital maps. As technology continues to advance, we can expect even more innovative applications of computer vision across a wide range of industries. The fifth AI use case pattern we have today is natural language understanding. While computer vision focuses on interpreting visual information, natural language understanding delves into the world of unstructured text, enabling AI systems to analyze and comprehend textual input. Leveraging natural language processing techniques, or NLP, AI systems can analyze and extract insights from different forms of text, including social media, documents, customer support tickets, emails, tweets, and more. Now let's have a look at some natural language understanding use cases, starting with automated document processing. In industries like supply chain, AI can rapidly scan, digitize, and extract insights from documents such as invoices, purchase orders, bills of lading, and customs documents. This automation replaces manual data entry and can process thousands of documents in minutes, leading to increased productivity, reduced costs, and fewer errors. Similar techniques can be applied to other sectors, such as claims processing in insurance, customer onboarding in banking, document verification and approval in government, and processing healthcare forms and patient records. For sentiment analysis, AI can analyze social media posts and news articles to gauge customer sentiment around companies, products, or services. It can also predict supply chain disruptions by mining data sources like news outlets, weather feeds, and unstructured reports, detecting potential impacts on various nodes in the network. AI-powered chatbots can recognize speech and text, understand intent, and respond in a human-like manner. These smart chatbots can be integrated into websites, online stores, social media channels, and mobile apps to assist with customer inquiries and tasks, reducing the burden on customer support teams and enhancing customer satisfaction. In addition to these use cases, natural language processing involves a range of tasks that can help machines interpret and generate human-like language, including machine translation, named entity recognition, text summarization, part-of-speech tagging, dependency parsing, topic modeling, and question answering. As we conclude our discussion on natural language understanding, it's worth noting the impact of the recent advancements in large language models like GPT-4. These state-of-the-art models have significantly enhanced AI systems' abilities for understanding and comprehension when dealing with text data. Businesses nowadays can build on top of these large language models by using APIs from companies like OpenAI, or by using open source models like Falcon 40B or Llama 2. This enables them to incorporate powerful natural language understanding interfaces and capabilities into their applications without necessarily going through the complicated process of building them from scratch. While natural language understanding revolves around text data, speech understanding, the sixth pattern we have today, delves into the realm of spoken language, allowing AI systems to comprehend the human voice and extract meaningful insights from it. It shares many applications with text understanding, with the added advantage of voice-based interactions. Voice-based chatbots, for example, can interact with customers as they speak and respond in a human-like manner. Smart call centers are already leveraging this technology to provide in-depth, real-time analysis of call data. AI can support agents by recommending the best resolutions, monitoring call script compliance, identifying customer sentiment, and conducting post-call analytics. This not only increases agent effectiveness, but also improves the overall customer experience. Voice-to-text transcription, powered by state-of-the-art machine learning, is another noteworthy application. In healthcare, it's used for transcribing physician-patient conversations for clinical documentation. Virtual home assistants like Amazon's Echo or Google Home rely on speech understanding to enable users to perform various tasks, such as playing music, asking questions, controlling compatible smart home devices, and setting reminders. Additional applications of voice understanding include voice search and voice biometrics for security. For example, some banks would allow their customers to verify their identity using voice recognition instead of lengthy verification cycles using security questions and such. Action optimization, the last AI pattern we have for today, aims to identify the best possible decisions or actions in various situations. To better understand this pattern, let's first have a look at the three major types of analytics. Descriptive analytics describes past events, such as sales generated in the previous quarter. Predictive analytics predict future events, like forecasting sales volumes for a new product about to launch. Lastly, prescriptive analytics focuses on determining optimal actions or strategies to address specific situation. It helps with answering the question, what should we be doing? Like, how can we sell more? Or what are the best decisions to make in certain conditions? Prescriptive analytics is where techniques like reinforcement learning come into play. Unlike traditional learning methods that learn from historical data, reinforcement learning involves continuous trial and error in real or simulated environments. The objective is to maximize a specific reward function, like the click-through rate on online advertisements, or the amount of time an autonomous vehicle could drive without crashing in a simulated environment. Although action optimization, especially using reinforcement learning, is not widely adopted in the business world compared to the other patterns that we discussed today, there are some real-life use cases that are being deployed in production in different industries. Let's take a look. Logistics optimization for supply chain operations, trajectory optimization and motion planning for autonomous vehicles, robots, and drones, production scheduling optimization for manufacturing, portfolio management and financial trading strategy optimization, and finally, optimizing driver allocation and order dispatching for rideshare companies. As we wrap up this episode, let's take a moment to recap our journey through the 7 AI patterns we have discussed today. We have explored the power of AI-driven prediction, delved into clustering, and explored anomaly detection use cases. On the way, we have touched on the power of computer vision, natural language understanding, speech understanding, and action optimization. In our next episode, we'll dive into the exciting and rapidly growing field of generative AI, covering the 8th pattern, content generation. We'll see how AI can generate in a human-like quality data like text, images, videos, code, and even 3D models. We'll be examining more than 30 use cases in this amazing field and discuss how technologies like ChatGPT, Midjourney, Stable Diffusion, and others are transforming different industries. We'll also be exploring the major AI use case patterns in this field, like chatting with enterprise data, AI agents, natural language-driven experiences, and more. So stay tuned and join us for our next episode as we continue to unravel the potential of AI in transforming our world.